Hello, welcome to my course Periodic Table and Periodic Properties of the Elements. This is the last module of this course. Here you will all study about the metals, non-metals and the non-metalloids. Hope you are enjoying the whole course. You have learned a lot all about the development of the periodic table, followed by the various periodic properties like ionization potential, electroaffinity, then ionic radii, electronic configuration, how SPDF orbitals get filled, then stability of half filled and full filled d orbitals, followed by the oxidation and reduction reactions, half reactions, and etc. Now in this last module we will go through with the metals, non-metals, metalloids and their properties. I showed this PPT you to earlier also. Here you can easily check all the yellow colored elements are metal in their nature. These purple color are in the metalloids in their nature, and all these green color compounds or elements are the non-metals. Now how you will check out that what is metal, which will work as metalloid, which will work as non-metalloid, non-metal, then how you will distinguish all these elements from each other on the basis of their properties, right? So here in this module I will explain you the properties by which you can correlate your element, that whether it will be a metal, non-metal or the metalloid, right? Now metal, whenever I want to give you the definition about the metal, what is a metal? Metal is generally a hard solid substance that has a shiny luster and it conducts heat and electricity. Properties such as high tensile strength, high fracture toughness, malleability and availability are just some of many advantages associated with the metals. As we are having lots of uses of the metal in our day-to-day life, the first metal were discovered accidentally more than 5,000 years ago, right? Now what are the metallic properties? Metals are generally malleable. They can be hammered or pressed permanently out of the shape without breaking or cracking or fissile. Able to fused or melted and ductile, right? So these are the main important characteristic of the metals. Metals in general have high electrical conductivity, high thermal conductivity and high density, right? Metals are generally not used in their pure state but as a mixture of their metal and non-metal constituent, commonly referred as alloys, and you might be aware of various types of alloys and their applications. At room temperature, most of the metals are solid and they have characteristically silvery shine, right, except for mercury, which is a liquid at room temperature, right? Now further metallic properties are the melting point of metals are usually high, but gallium and cesium are those metals which are having such low melting point that they can melt if you keep them on your palm itself, right? Then another exception to general characteristic of metal is alkali metals such as lithium, sodium, potassium, which are so soft that they can be cut with a knife, right? Whereas earlier I told you that metals are solid compound, you cannot cut it. You can make it thin sheets, but you cannot cut it. But alkali metals are the exception. These metals you can cut via your knife, right? Lead, mercury, titanium, chromium are bad conductor of electricity. All these are the exceptions, and bismuth is the poorest conductor of heat, right? Now if suppose you want to explain the physical properties of the metals and the uses associated with it, then you can look at here. You just look at here. If we are talking about the melting point of the metal, generally metals are solid at room temperature except mercury. So this is the reason why we are using mercury in thermometer. No any other metal we can use in the thermometer. If we are talking about its density, they are very dense and very form less to and they are very less than the water to very dense, then means they can be higher from the water, or they can be heavier from the water, they can be lighter from the water, as the for an example sodium and the lead. So I used in aircraft because aluminium is used in aircraft because of low density, right? Then the thermal conductivity, all metals conduct heat well. So aluminium and stainless steel used in cooking pans, if they conduct the heat, then you won't be able to cook in your stainless steel, right? Um, then malleability, metals can be bent into different shapes. Car bodies made of flat sheets because they are having the characteristic of malleability, right? Then the strength, some metals are very strong in their nature. Iron used to make grinders and reinforce concrete because they are having very strong strength. Then the electrical conductivity, all good conductors are solid or liquid. Copper and aluminium used to make electrical wires because they are very good conductor and cheap in their cost, right? So all these were their physical properties of the metals. Now you can look at here, this is the three-dimensional arrangement of atoms in a metal. You can clearly look at out how tightly they are packed to each other. They are having strong electrostatic force of attraction. They are so tightly attached to each other, and due to this they are having high density because there is small empty space between closely packed atom. Here this is the way you cannot you are not able to see the gaps in between, but here the gaps are clearly visible, right? So these are the various physical properties of the metals. Now chemical properties, if you want to check out the chemical properties of metal and non-metal, so major difference of the metal and non-metal is that metals are having the tendency to donate the electrons, whereas non-metals are having the tendency to receive that electron or an electron. Now displace hydrogen gas from dilute acid. A metal, any metal is capable to replace the or displace hydrogen from any acid, whereas non-metals are not able to do it. Then react with oxygen to produce basic oxides, as sodium is reacting with oxygen and it is producing the sodium oxide, right? They produce the with oxygen to produce acidic oxide. Here with metal you are getting the basic oxide, whereas with non-metal you are getting the acidic oxides. React with hydrogen to produce hydrides, as calcium hydride. They react with hydrogen to form the covalent compound as the carbon plus hydrogen, that is the methane. Now various types of metal, if you want to check how many types of metals do we have, so as per their activity and their reactivity we are having 5 types of the metals. Basically noble metal, they are very unreactive metals, silver, platinum, gold and palladium. We are having the ornaments with them. Alkali metals, these are highly reactive with low melting points and these are very soft in nature, example potassium and sodium, right? Then the third is the alkaline earth metal. They are very less reactive, higher melting point and harder than alkali metals, example calcium, magnesium and the barium. Transition metals, hard, shiny, strong and easy to shape, example iron, chromium, nickel and copper, right? Then the fifth category is of other metal, in which you are having the metals which are having diverse properties rather than the general properties, and that's why they are very having versatile uses or applications. For an example, the aluminium, gallium, tin, thallium, lead and the bismuth, right? Now if you want to classify the metal on the basis of their corrosion, we are having basically 2 types of the metal, the ferrous metal and the non-ferrous. As the name is indicating, ferrous means the iron. Ferrous metals include cast iron, steel and the various steel alloys. The only difference between the iron and the steel is the carbon content, right? Cast iron contains more than 2% of carbon while steel contains less than 2%, right? Another type is the non-ferrous metal. Non-ferrous metals are the metal that do not contain iron. Example include aluminium, zinc, copper and the brass, right? So in general, what is the main difference between the ferrous and the non-ferrous? Ferrous means which are able to corrode or which can corrode easily, which is having the property of corrosion, right? Means they can be affected by the atmospheric moisture and the water, right? So non-ferrous do not corrode as quickly as ferrous metals due to the rapid formation of thin protective oxide layer on their surface, although they are still susceptible to corrosion when exposed to atmospheric condition, right? Then non-metals. After metals you need to understand what are non-metals. Non-metals are those elements that generally lack the property of metals or have their properties opposite to that of metal. As I told you that metals are very strong, luster, they have ductility, malleability. So in reverse, non-metals are not having any of this property. Their thermal and electrical conductivity are usually poor. They are not very good conductor of electricity and thermal energy, thermal heat as the metals are there. They are brittle and do not possess the properties of malleability and ductility. Means whenever you want to make thin sheet of these non-metals, as you are able to form with the metals, they will get breakdown, right? Elemental non-metals mostly are in gaseous state at room temperature, while others are solid. Bromine is a non-metal which is liquid. Non-metal lack the shiny luster except iodine. Generally, non-metals have low melting and boiling points. Carbon is a non-metal that can exist in different forms called allotropes. Diamond is an allotrope of carbon and it is the hardest natural substance known and has very high melting and boiling point. So it is an exception in the case of non-metal. Also graphite, another allotrope of carbon, is a good conductor of electricity, which is also another exception, right? Non-metals are less dense as compared to the metals. Now, comparison of metal and non-metal. Already I told you there is a vast difference between the metallic and non-metallic properties. Whatever the properties metal have, non-metal don't have, right? So it is the comparison. If you are talking about the appearance, metals are shiny, whereas non-metals are dull. If you are talking about the melting and boiling points, metals are having high melting and boiling point except mercury, whereas non-metals are having lower melting and boiling point rather as comparison to the metals, and except for the bromine, which is a liquid at room temperature, right? If you are talking about the density, metals are having high density, whereas non-metals are having low density. Now if you are talking about the strength, metals are very strong, whereas non-metals are not. If you are talking about the malleability, metals are malleable, right, whereas the non-metals are non-malleable. Ductility, they can be drawn out to make wires, means whereas you cannot make wire with the non-metals. Heat conductivity, metals are good conductor of heat, whereas non-metals are not good conductor. They are very poor conductor of heat. If you are talking about the electrical conductivity, again metals are very good electrical conductor, whereas non-metals are not the good conductor of electricity. Now general properties of the metalloid. We are having another term, that is the metalloid, means which is in between with the metal and the non-metals, right? So metalloids are typically look like the metals, means they are having the appearance like the metal. However, these elements often behave like the non-metals. Physically, metalloids are brittle, somewhat shiny substance that are usually solid at ambient temperature. These elements usually have intermediate to very strong electrical conductivity. Metalloids are known to have electronic band structure that are similar to semi-metals or semiconductors. Chemically, these elements usually act as non-metals. These elements generally have intermediate energies of ionization value and value of electronegativity. Metalloids are known to form amphoteric and weak acidic oxide. These elements have the ability to form metallic alloys. Many of other physical and chemical properties of metalloid in a sense are intermediate between the metals and the non-metals, means you can easily understand metals and non-metals are quite opposite to each other. Whatever the metals are having, non-metals are not having those properties, but whereas metalloid, they are in between the metal and non-metal. They are sometimes behaving like a metal, and non-metalloid sometimes behaving like the non-metalloids, right? Now we are having various applications of the metalloid. Metalloid and the compounds of metalloid are widely used as alloys, biological agent, flame retardant, catalyst, glasses and optical storage media. Metalloids are also known as to have application in optoelectronics, semiconductors, pyrotechnics and electronics. Alloyed form, when they combined with transition metal, are extremely well represented when they comes into connection with the lighter metalloids. Boron has ability to form the intermetallic compounds. Furthermore, nickel boron alloys are used as ingredient in the engineering industry for welding alloys and case of hardening composition. Silicon alloys of aluminium and iron are widely used in the construction and automotive industry. Germanium is also known for several applications, especially in the coinage metals in particular. So now you can easily understand all the three, metal, non-metal and the metalloids. They are very much different from each other, but everyone is having its own application. Metals are as being good conductor of electricity, you are using there. Non-metals, they are poor conductors, so you are using all these in another way. And metalloids being the in between with the metal and the non-metals, you are using mostly the metalloids, right? So hope, dear students, hope that you have understood about the metal, non-metal and the metalloid, and all about this course, that what is, how the periodic table development taken place, then what are the various periodic properties, how their trends goes on in periodic table. Means now you are able to understand the properties, periodic properties and its trend among the periodic table, as well as you can assign any compound as that whether it will be a metal, non-metal or the metalloid. Hope you have enjoyed my whole course. Keep learning and keep trying. Okay, good luck and thank you very much.